Okay, welcome back to yet another lesson. There's some stuff that we had left out that we might need to go back to, which is our data types. And we had not really defined how they work. And here are some of the classifications that we've got for our data types. C has different data types for different types of data and can be broadly classified as primary data types, secondary data types, where our primary data types are characters, integers, float, double, void. Our secondary data types are arrays, pointers, structures, unions, and enumerators. We can further define these as basic data, enumerated data, void data types, and derived data types. So we're saying with our basic data, that's your character, your integer, and your float and your double. Your enumerated data types, these are values that only accept integer variables. Our void data types, these are empty values that C allows, although we can be able to pass through any type of data type, either character or integer. We've also got derived data types, which deals with arrays, structures, and unions. So if we're to put it as a list, here's the list that we've got for our elements, which are our basic data types. We've got our integer, our float, and our character. We've got unsigned integers, we've got signed integers. And for our signed and unsigned, we work with int, short int, long int. We've got our float, double, long double, our character, signed character, unsigned character. At the same time, we can then put them in a table like this. I will make this document available so that you see some of the things that we will be talking about and the things that we need to do. So let's quickly get to our code blocks and we create a project that shows us some of these elements. So we're simply saying we create a project and we want to get into the gist of how these data types are working. So we can say data type plus examples. Okay, so we don't want to have too many examples because some of the content that we've got will work with in the later lessons that we'll have. So for example, we actually just want to know how these elements work. Our character, our integer, our float, our double, and our void. The secondary data types will actually work with them as we proceed because we are getting into them when we continue with the future lessons. So let's just say we want to see how these data types work. Okay, some of them we've already used before. We spoke of void. What void simply does is it allows us to work with empty data. Okay, so for example here I can change this and say void main, and then when we run it, it'll give us a return, but in this particular case it's not giving us a 0 now, it's now giving us a 1. So that's an example of a data type. So changed from int main. What this simply means is we've got an empty value, which is our void data type. So we don't necessarily expect an integer to be returned, but we expect that by putting the keyword void, we can be able to put certain aspects and attributes to our data. Okay, everything else pretty much remains the same. Our float, our integer, our double, our real, all pretty much give us the same content. But where we want to go to the next step now is we've learned that int a is equal to 4. We have declared our variable and initialized it. We've also learned that character b is equal to, those need to be single quotes, is equal to h. We've created our variable and we've initialized it. What we haven't learned, however, is we can modify these values. We can say long int, and then we say h is equal to 34. We can also say unsigned character j is equal to 9. So what this then means is we are simply modifying our storage space, okay? And then our storage space where each of these elements is stored pretty much increases. All right, so to then see what this gives us, we can simply put a printf, and our printf should give us the content that we want to see. Okay, so we can say size of h. Okay, we put our percentage d, we put a new line, we close, we put a comma, I think I made a mistake somewhere. It's not supposed to be blue. Okay, let's just try it again. Right, we want to put our content size of, we can put a size of h, and then we say size of h equals percentage d. We'll put a new line, and then this should run and give us a size. Let's just run it and see that it's telling us that the size of h is 4. So this won't pretty much make sense because it's all to do with memory space and how each element is then stored and how we will then be able to access that particular point in memory. So at a later stage, we'll actually work with what are known as pointers, and we'll be able to see how we manipulate these values that are stored in memory and how we can use them to give us the best result that we're hoping to get. Okay, so the next element that we want to work with is, we've seen that we can just modify our variables. So here we have modified our variable. Here we've searched for the size of the variable. Okay, the next thing that we want to do now is we want to work with what are known as qualifiers. Okay, qualifiers. Okay, so qualifiers, I've got some description that is here that tells us a bit about qualifiers. So our qualifiers are namely two. We've got constants and we've got volatile. Okay, so it says constants are things which are unchangeable. So if they are not changeable, they are constant. Whereas if anything is changeable, then it's volatile. But some may then ask that already our variables are already volatile because we can be able to change them. What's the point of having a volatile? What is the point of having a constant? It's pretty much a preprocessor directive, or it's telling our code blocks to be able to be prepared for whatever comes in terms of that variable. So it then knows how to handle the variable. So if a constant is then forced to change, we are then supposed to expect an error, although as we further get into our learning, we can realize that we can manipulate our code based on what we expect to be able to do. Okay, so one such comparison can be this one, where let's see if I can just get this table to fit. Okay, something along those lines. Okay, this looks a bit better. Okay, we've got a comparison of how these two pretty much work. I don't want to give you too much notes or too much to work with, because the majority of my lessons have been working with having fixed items. Okay, so constant variables are unchangeable, whereas volatile are changeable. Constant variables can be created using the keyword const. Volatile needs to use the keyword volatile. An example is const int is equal to 16, where we are declaring our variable and initializing it. And another example is volatile int j is equal to 30, and there we're declaring our variable. A constant should only be initialized at the time of declaration. A volatile can be initialized anytime. By default, all variables are not constant. By default, all variables are also not volatile. And then a constant variable otherwise is known as a read-only variable, and then a volatile variable is known as a read-write variable. Another way to achieve constant variable is by using the define preprocessor directive, and we work with this by having a define a is equal to 5, and then let's just copy and paste this somewhere so that we see how it read. Okay, paste it there. That didn't work. Let's see if we decrease. There we go. Paste. Right, so that was just an example of how this works. Let's create examples of how these qualifiers work. So we now know that a qualifier is a const int num. Okay, we then initialize it to 6, and we have a volatile int num2 is equal to 7. Okay, so in other words, we can then say when we print f to see the contents of these two values, we can actually be able to see num is equal to %d and num2 is equal to %d. We put a new line, we put a comma, num and num2, like that. So if we run that, we'll be able to see what each element is. Okay, but on the other hand, now if we then want to say num is equal to 10, like that, if we run it, so let's proceed to actually show how we can also use these variables. Okay, according to our notes, we also noted that we can use the define keyword, okay, to denote the exact same concept. Okay, let's say we want to use the define keyword, which is a preprocessor directive. That can also give us the same result. Okay, in this particular order, let's say we want to work with define. So it's hash define, and then we need to put the value that we want to work with, which we can in this case call jump, and jump is equal to 10. Okay. At the same time, we can now be able to print jump. So we put a printf. We come to our quotations and we say jump equals %d. We put a new line, put a comma, and then we put jump. Okay, so as you can see now, we've also done the same concept as our constant, although in this particular case we did it as a preprocessor directive, and we can be able to see what jump is equal to. However, we have not seen what num2 is equal to since we had not put a printf. Let's actually put a printf and see what this gives us. So this gives us %d. Let's not put any text because we know exactly what we want to do. So it's num2, so that we can see the change in the variable. Okay, so initially our num2 was equal to 7. We changed that to 10. We've also put our jump to be equal to 10. However, interestingly, we can actually create a program that does certain attributes, because we know that these contents, or this content, is unique and does not change. So it's a constant. So we can create a project that we just want to see how we can play with a constant, for example. Okay, we want to play with a constant, and here's how we will do it. Okay, we want to define every element that we hope to work with and see how it plays out. So we can say a const int, we call it var1, we then say that is equal to 7. We also put a const int var2 is equal to 9, and then we say a const, we can also do this for character as well. We then call it new line. We then say that is equal to our new line character. Right. At the same time, we then want to be able to display this content. So we can say printf, and our printf will be the following: var1 and var2 gives %d we put a new line, put a comma, and we say var1 multiplied by var2, like that. Put a semicolon, and we can be able to run it. And we then realize that 9 multiplied by 7 gives us 63. However, we have also not used our new line. Let's replace our new line at this point, and we put a comma, and then we put new line, like that. So if we run it, we're supposed to get the exact same result with our new line as we would have got if we put our new line in that particular instance. So hence, when we are working with our constants, we can be able to create certain elements that we'll be able to actually store within the constants and be able to use those variables or those values as part of our code, or as part of how we'll be doing certain things and certain elements that we hope to work with as we are programming our programs and how our programs will work.